Okay, so today we're on 6.3 combinations. Our learning target is I can count the number of ways a combination can happen. In other words, I can find the total number of outcomes for a combination. I can also distinguish between types of permutations and combinations to identify the correct counting principle. Combinations. What are combinations? Combinations are the number of ways something can happen or the total number of outcomes when an order of items or specific titles does not matter. In other words, when a different order or different titles would not make the outcome different. So that part's super important. The order does not matter, okay? So when we did permutations, the order did matter. That's what sets these two apart. In a combination, order does not matter. In a permutation, order matters, okay? So these are used for choosing groups of people who don't have any difference in the order or job that they do. So some examples: choosing a group of 5 students from a class of 30 to help a teacher carry books to the library. Awarding 4 of the 12 entries with an honorable mention, or choosing 3 books from the 10 on your shelf that you'd like to read this summer. Can you see how each of the students' honorable mentions or books are not more important or serve no different purpose than the others? That's what makes these combinations. Okay, so let's take a look at an example. So how can we choose a group of 5 students from our math class to help me carry books to the library? Okay, so let's say that we've got 19 students in our class. All right. So let's think about this in terms of a permutation for a second. If I choose 5 students, and we'll say I choose Kyle, Josh, Emma, Kenna, and Zach. If I chose those 5 students, and then I chose Josh, Kyle, Emma, Kenna, and Zach, would those two be the same or different in a permutation? Well, in a permutation, order mattered. So switching up how I chose Kyle and Josh there made this a totally different possibility. And the same thing if I chose it backwards. If I chose Zach, Kenna, Emma, Josh, Kyle instead of Kyle, Josh, Emma, Kenna, Zach, that would be a complete different line. But in a combination, we're just choosing a group of 5 students. It doesn't matter if we choose Kyle first or if we choose Josh first. These are the exact same in a combination. Okay, so in a combination, these are the same. Okay, so we have to take into account that in a permutation, we're going to have a lot more options because these 3 are all different lines. And there's a lot more that repeat than just these 3 lines. So what we want to do is think about, like in the last notes, when we had a circle or when we had a word with repeating letters, we always divided by something, okay? We divided by something to account for the fact that some things can repeat. So let's just take a look at the formula for permutation, okay? So the formula for permutation is right here. It's n factorial divided by n minus r factorial, okay? So that's the formula for permutation. But if we're looking for the formula for combination, which is going to be back on our notes, it's going to look really similar. The only difference is we're going to divide by an extra r factorial, okay? So what a combination is, it's just a permutation that you divided out all those repeats because order doesn't matter. It doesn't matter how I choose those students. It's the same group of students. Okay? So let's see if we can do this in our calculator. It's going to be exactly like the permutation was in your calculator. So for number A, for example, what you're going to do is you're going to put a 5 in your calculator. You're going to push the PRB button, and then you're going to, instead of doing the NPR, because that was permutations, now we're in combination, you're going to push NCR, which is the second option, and then you'll put a 3 in. When you do that, and you put that into your calculator, your answer should end up being 10. Okay? So when we do 5, choose 3, we get 10 as our answer. Okay, now let's do it again with 5, choose 2. So we'll push 5, PRB, NCR, and then 2, push enter, and we'll get 10 as well. Okay? Now let's do 22 choose 22. If we put that into our calculator, we're going to get 1 as our answer. Okay? Now if we choose 9 choose 0, we're going to also end up with 1. Okay, for 15 choose 1, when we put that in our calculator, we get 15. Now for F, find the number of combinations 18 objects taken 4 at a time. Okay, well, our N is going to be the total number that we have. Well, we've got a total of 18 of them. Okay, and then we're going to choose 4 of them. So we'll put it in our calculator just like that, and we'll get 3,060 as our answer. Okay, so let's talk about some of these answers here. Okay, so why are the answers to A and B the exact same? Let's think about this. If I have 5 different objects here, and then I go back and I choose 3 of them, okay? So I've chosen these 3. Well, that leaves me with 2 things over here. 2 objects, 2 people, 2 whatever. Okay? Well, in the first one, we end up with 10 different groups of 3 that we can choose. Well, for every 3 we choose, we leave 2 behind, which means if we did this in reverse order, and instead of choosing 3, I chose 2 to begin with, well, that would leave the 3 that I originally chose left over. Okay, so because the 3 and the 2 add up to my total of 5, 5 choose 3, and 5 choose 2 are going to give me the exact same answer. Okay? So now let's talk about why is the answer to C such a small number when the permutation of the same number last time was so huge. Okay? Well, if I've got 22 and I'm choosing 22, so say I lined up 22 students, and I choose all 22 of them, then it doesn't matter what order they're in, whether they're A to Z, Z to A, mixed up with their friends, however you want to do it, it's the same line of 22 students, because order doesn't matter. So when I have 22 of something and I'm choosing 22 of them, it's always going to end up that 1 is my answer. Okay? So we can say here, because order doesn't matter, okay. So now, why is the answer to E the exact same as the permutation? Well, if we think about it, when we did 15 permute 1, we have 15 objects and we're only choosing 1 of them. Well, if you're only choosing 1 object, you can't change the order of that, because you don't have multiple things to change your order. You can't pick one and then pick the other. You're only picking 1 object. So whether I'm doing a permutation or a combination, if I'm only choosing 1 thing, the answers are going to be the exact same, because there is no order. So it can't matter or it can't not matter, because there is no order. So when we're choosing 1, there is no order. When dealing with the number 1. Okay? All right. So, discuss why the following are combinations instead of permutations, then evaluate. So, how many different groups of 4 students can be chosen from the student council to attend a leadership conference next month? Okay. Well, I'm not assigning these students any titles or any positions. That's why order doesn't matter. It's just 4 students that I'm picking. Okay? So let's say that our student council has 6 people in it. Okay, and we're choosing 4 of them. Okay. If we put that in our calculator, it's going to be 15. Now this example wants us to use our school student council. I'm not sure how many students there are, so that's why I just said 6. But the rest of these examples are all going to give you your total amount of numbers. So the reason I chose 6 is because this example is kind of a bad one. It doesn't give you that number. The rest of them will all have the number already included in it. Like number 2 says a team has 13 players. Before each game, the coach picks 3 players to represent the team at the coin toss. How many different groups of 3 players can the coach pick? Okay, well, we need to choose. Our answer is going to look like NCR. Okay, well, we need to find our N. The N is always the total amount of things you have. In this case, we have 13 players. And we're choosing, right here, it says we're choosing 3 players. So we've got 13, choose 3. If we put that in our calculator, we're going to have 286. Okay. A pizza place lets customers choose 3 toppings from a list below to put on their pizza. How many different groups of 3 toppings can customers choose? Okay, well, we've got pepperoni, sausage, peppers, mushrooms, ham, and pineapple, which means we've got 6 different toppings, and we're choosing groups of 3. So 6 choose 3 gives us 20. Okay. So now Chloe wants to check out as many books about dolphins as she can from the library. The library only allows patrons to check out 4 books at a time. If there are 15 books about dolphins available at the library, how many different sets of 4 books can she choose? Okay. Well, we've got 15 total books, and we're choosing groups of 4. So we've got 15, choose 4. Which is going to give us 1,365 when we put in our calculator. Okay. So Mrs. Arnold's math class consists of 12 sophomores, 7 juniors, and 5 seniors. How many ways can she create a 2-member committee of sophomores if each sophomore has an equal chance of being selected? Okay, so for this example, we're only looking at the sophomores. So I've got 12 total sophomores, and I'm choosing a committee of 2 members. So I've got 12, choose 2, which is going to give me 66 different groups that can be formed. Okay, now in the same math class, we still have 12 sophomores, 7 juniors, and 5 seniors. How many ways can she create a 3-member committee with 1 student from each class? Okay, well, just looking at the sophomores first, we have 12, and we're only choosing 1. So that is going to be our sophomores. And then we have 7 juniors, and we're still only choosing 1 from that class. And then we have 5 seniors, and we're only choosing 1 from that class or grade. Okay, well, from the rule up above, we know that if we have anything choose 1, it's just going to give us our answer back. So this is going to give us a 12, this is going to give us a 7, and this is going to give us a 5. So now we have 3 independent classes or grades. And if we remember from our previous lessons, when we have independent events, all we have to do is multiply those together. So if I have 12 times 7 times 5, I end up with 420 different committees that can be made if we choose 1 student from each class. Okay. So, evaluate the following in a logically correct method. Be sure to determine the type of problem it is first. So we have to choose whether it's a combination or a permutation, and then we have to evaluate it. Okay, so it says Joe is trying to form a committee of 5 people to help with the blood drive. 17 people have volunteered. How many different groups of 5 can be formed? Okay. Well, we're not assigning any specific roles or any titles to anybody, so it's just a group of 5 people, which is going to make this one a combination. Okay? Now that I know it's a combination, the hard part is over. The rest will be solved in my calculator. So I know I have 17 total people that volunteered, and I'm choosing groups of 5. So I'll put that in my calculator, and I get 6,188. Okay, the next one. Joe is trying to form a committee of 5 people to help with the blood drive, where each person would have a specific role. 17 people have volunteered. How many different groups of 5 can be formed? This is the exact same question as before. The only difference is now we're assigning specific roles. And because we have specific roles, the order matters. So this one's going to be a permutation. Okay? And we're going to set it up the exact same. We still have 17 people. This time we're permuting, and we are doing groups of 5. If I put that in my calculator, I get 742,560. Okay. Looking at number 3, a sandwich shop lets customers choose the order in which they stack the meat on a sandwich because people think it affects the taste when the meat is in a different order. How many ways can 3 types of meat be stacked if there are 10 types of meat to choose from? Okay, well, this one flat out says when the meat is in a different order. So order matters in this one. So this one is going to be a permutation. Okay, now we know that we have 10 different meats, and we're choosing or permuting 3 of them. If we put that in our calculator, we get 720 different sandwiches that you can make. Okay, looking at number 4, a sandwich shop lets customers choose 3 types of meat to put on a sandwich. How many different sandwiches could be ordered if there are 10 meats to choose from on the menu? Well, this is basically the same question, but now they're not letting people choose the order in which they stack their sandwich. So this one is a combination, and it's set up the exact same way. We still have 10 meats, but we're choosing 3 for a sandwich. If we put it in like that, we get 120 as our answer. There's less because we're accounting for the fact that whatever way they put the meat on, it's the same sandwich. Number 5. The school is forming a committee of 3 teachers and 6 students to help put on the next dance. If there are 5 teachers and 20 students to choose from, how many different committees can be formed? Okay, well, let's set up 2 different equations or 2 different functions here. First thing we have to do is decide whether we're going to set up 2 combinations or 2 permutations. Well, we're just making a committee of 3 teachers and 6 students. It doesn't matter which order, and we're not assigning any roles. So this one's going to be a combination. So if we look at just the teachers, let's set up a combination for the teachers. Well, I have 5 total teachers, and I'm choosing 3 to be on my committee. Okay, now if I'm looking at my students, I've got 20 students, and I'm choosing 6 of them to be on my committee. And then if I multiply those together in my calculator, I get 387,600 as my answer. Okay, now the school is casting parts in a play where 3 teachers and 6 students will fill the roles. If there are 5 teachers and 20 students to choose from, how many different casts can be formed? Well, now we're choosing parts for a play or roles for a play. So now it matters, because if we choose one student to be the lead role, then it's going to be different if another student takes over the lead. Okay, so now we're going to be doing a permutation because we're assigning roles. Okay, but it's going to be set up the same way. I've still got 5 teachers, and I'm choosing 3 of them, but now it's just a permutation, not a combination. If I put that into my calculator, I get 1,674,432,000 different roles that can be formed, different casts that can be formed. Okay, last but not least, how many different outfits can you put together if you need to choose 1 of 7 shirts, 1 of 5 pants, and 1 of 3 shoes? So the first question we need to ask ourselves is, are we doing a combination or permutation? Well, I noticed something here that we're choosing 1 of 7 shirts, 1 of 5 pants, and 1 of 3 shoes. So we're always choosing 1. And earlier we decided that if we're choosing 1, it doesn't matter whether it's a permutation or a combination. They'll give you the exact same answer because when we're only choosing 1, we have no order. So we can't say whether it matters or not because there is no order. Okay, so whether you do permutation or combination, when it comes to shirts, we have 7, and we're choosing 1 of them. When it comes to pants, we have 5, and we're choosing 1 of them. And when it comes to shoes, we have 3, and we're choosing 1 of them. Or you can shortcut this by just saying 7 times 5 times 3. When we multiply those together, we get 105 different outfits that we can put together. Okay, don't forget to do your pathway and do the Delta Math online.